All right, to try to make things a little bit smoother, I'm going to walk you through the lab for this week, which is Lab 3, Plate Tectonics. Okay, so as you've probably picked up by now, you go into modules when you're at the home page for our class. This was the first module you guys did. Second one was scientific method and the solar system. And we just did geologic and topographic maps. Now we're working on plate tectonics and continental drift. If you haven't already done so, you need to watch the lectures first before you try to do the lab or the development of a theory, which is a cool infographic, or the plate tectonics quiz. Okay, you want to watch these first. If you haven't watched them through this link, which is listed underneath the module, this is how you get your participation points, so keep that in mind. You can click on this module kind of page, if you will, which will give you kind of a little graphic, what you should obtain from this module. It gives you the link to the chapter, so chapter 2 is here, which is plate tectonics. So you click on this and it will take you over to your textbook, which is the opengeology.org. It's taking a minute to load. So while that's loading, let's continue. So this has a link to the continental drift and rise of plate tectonics lecture on YouTube, and the embedded one where you get your participation point is also listed here. So you can click on this one here, or you can click on the one on the previous page we looked at. So both lectures are listed here. Usually I would combine these into two lectures, or into one lecture, but I've been combining them, or separating them, excuse me, just to kind of make it so you're not watching so much information, like an hour to an hour and a half of information at once. Okay, so if it feels like it's a lot of lecture, I'm trying to divvy it up a little bit so that you're not bombarded with so much information in one sitting. So I would suggest watching them separately, because back to back, it's good, but it's a lot of downtime. And then you have the lab assignment here, you have your infographic assignment here, and plate tectonics quiz here, and then it says when it's due. Now, as you're navigating through this, you can just click next. If you click next, it'll take you to the first lecture. So this should launch the external play posit. So it'll tell me that I am attempting this as a test student, and you just click play and you go through it. Okay, I know some of you have had some issues with this. This does not work on the Canvas app. It's not my favorite thing in the world, but it works for now. I'm going to be messing with Canvas Studio here shortly, and hopefully we can get the integration of the quizzes into the lecture a little bit easier. That way maybe you can actually do it on the app, but for now we need to do it on a desktop. Okay, once you're done with this one, it'll save your score and put it in your gradebook, and then you can go to the next one and start working on that. Okay, so this next one is just plate boundaries. Okay, and then you would go next would be your plate tectonics lab. Okay, now you can read through the chapter first, and one of the things that's really nice about the chapter is that after each section here, there is a basically, did you get it? So let me find one here. So here's a good one. Did I get it? So you can match the different phrases with the proper word that is associated with that phrase. So this one is giving you whether it's continental drift or plate tectonics, which of these things supports which theory. Is it continental drift or plate tectonics? So matching fossils and rocks, you learned from lecture, was continental drift. GPS measurements would be more so plate tectonics. Mid-ocean ridge was found with plate tectonics. Ocean trenches were found with plate tectonics. Matching coastlines, that was a continental drift. Oops. Lined up earthquakes, that would be plate tectonics. Warm places are glaciated, continental drift. Cooler places with tropical fossils, continental drift. And paleomagnetism was plate tectonics. So you'd go through and kind of do this and then go, okay, check. You got 9 out of 9. So now you know that you're kind of on the right track for understanding this stuff. I know that the last subject was not in your book, And believe me, that's a pet peeve of me and geology books right now, is that topographic maps is never really covered in depth, yet they want you to be able to read maps when you're doing continental drift and you're doing fossils and you're doing faults and plate boundaries. You need to still be able to read maps. So I think a topographic map section is needed, but none of the books that I've ever seen really have more than maybe a page explanation, which I don't think is enough. But I'll get off my soapbox with that. So then you can move on to the next section and you can do another did I get it at the end of that section. So here's another one. So this is about the different layers of the earth. Okay, so the book is pretty good because it does do a lot of did I get it, which is awesome. And there are animations and stuff in here. So make sure you're using the book. It will really help you. Okay, so let's go back to the lab and I'll actually describe the lab. Okay, so once I'm done with this video, I'm going to post it here in the instructions, and then that way you can watch it. Obviously, if you're listening to this, you've already figured that out. So we're going to take the quiz, and I'll walk you through some of the things. So if you've already taken this, this was not here originally. I did put this here. It was the second slide in the second lecture. But in case you didn't get it, I put it right here in front of you so that it's a little bit easier to find. So when you're identifying these plates, you're just going to use this map. You're going to want to use your ability to recognize the different landmarks or the different continents. So like this is South America right here. This is North America, Australia, Africa. This is Europe and Asia, things like that, okay? So that you can identify these plates. Okay, so there's 3 of those, and then you get into working with some different websites. So the first one here is a dynamic earth. And you're going to want to make sure that your flash is enabled, okay? So you'll start exploring. You'll click on the different portions, and it'll tell you different things about the different layers of the earth. Then it'll start asking you different questions about what the earth looks like now versus what it looked like 250 million years ago. So you'll go through all of these different pages, and it'll kind of click you through to the next, okay? And then once you're done with all of these, it'll take you to the challenge. And here you have to place where all the plates lie. And then that's where you stop. I know that there is another one called Slip, Slide, and Collide, but we haven't gotten to fault yet. That's next week. So make sure you stop at plates and plate boundaries after this challenge. So once you're done with this challenge, it'll give you a score, and then you just need to screenshot this. If you can't screenshot it on your computer, take a picture with your phone, something like that. And then when you go back to the lab, you'll upload it here. So you'll just choose File, you'll go into whatever your files are, and then upload it here. Okay, so that's the dynamic earth. The next one is looking at plate boundaries on a map. So this map is pretty cool because it gives you different things that you can add. So you can add the plates to the map. So this is a very nice outline of all the plates. You can look at where the major earthquakes are, plate movements, plate boundaries. Vent fields are volcanoes, so this is where we see any kind of magma coming up to the surface. You can look at fault zones and subduction zones. So this makes it a very busy map. But on each question, it will tell you what to turn on. So for question 5, you turn on plate boundaries and vent fields. Okay, so we just want the vent fields and the plate boundaries. So then it asks you to look at the map and where are most of the volcanoes located with respect to tectonic plates? What are they near? So if you look at where all of the volcanoes are mostly located versus where all the boundaries are mostly located, you might see a trend. Okay, so that's what that's asking. Question 6 asks you to turn on vent fields and major earthquakes. So here we'll turn off plate boundaries and we'll turn on major earthquakes. And you see any correlation there. So your options are the largest earthquakes are found near transform plate boundaries, the largest earthquakes are near subduction zones, divergent boundaries produce the largest earthquakes. So you can kind of tell based on the number of major earthquakes around a particular fault line what you might see. Okay. Then we get into the next one is looking at velocities. So we're going to exit this dive and discover. And we're going to go over to an Navco GPS velocity. So this is showing you how fast the plates are moving in different areas. So we want to follow the directions. So it says we want North America, NAM 14 Navco. So you just want to make sure that's usually what it comes up as, so just leave it there. And that's what you want to use when you're referencing the map. So the first thing you want to do is you want to zoom out so that you can see Washington and Baja California. So right now it's zoomed into San Francisco a little bit. So you do have to hit Control and then scroll. So you want to be able to see Baja and, oh, that was too far. Baja and Washington. So we got Washington up here, Baja California down south. Okay, so then it says unclick display vectors and click display plate boundaries. And then you want to click draw map. So we unclick our vectors. So all those blue lines will turn off, display plate boundaries, and then we want to draw map. So now it's just put the plate boundaries on the map for us. Okay, when you're looking at the map, it does have a legend down here or a key. And when we're looking at the plate boundaries, it tells you which plate boundaries we've got, right? So the white is the continental convergent, yellow is continental rift, this dark red is continental transform, this brighter red, or actually that's pink, oceanic convergence, red oceanic spreading rift, green oceanic transform fault, blue subduction zone. Remember, subduction zone is convergent. Okay, so you'll look off the coast here. What boundaries do we have? Do we appear to have divergent, convergent? Strike slip is technically transform. I'll change that to transform. I don't like that term. Or do we have all three boundaries found here? So you would take a look at this map and decide what you think. Okay, what type of boundaries you're in California specifically? Click all that apply. Okay, so if you zoom into California, so California being here, what do we have? Okay. Now we're going to change the map a little bit. We're going to click Display Earthquakes and Show All under how many markers are displayed. Okay, so we're going to display earthquakes. Under how many markers are displayed, we're going to put Show All and draw the map. Okay, so now we have a bunch of earthquakes plotted on our map. And now we need to decide what, if any, is there a correlation noted about earthquakes and plate boundaries. So do you see some sort of correlation with where most of the earthquakes are occurring and where the plate boundaries lie? Okay. Now we're going to look at earthquake depth. Are the earthquakes in California deeper or shallower in Washington? Okay, so we'll zoom out again. A little too far. So we've got a lot of pink down here in California, and in Washington we have pink and blue. So if we look down on our earthquake depth, most of the pinks are between 10 and 20, and then the blues are 70. Okay, so would you say that Washington or California would be deeper? So then here, you would say that California is either deeper or shallower than Washington. One word, deeper or shallower. No uppercase, okay? Just keep it all lowercase. These text boxes are very case sensitive, so I'm trying to eliminate them as best I can because they're not working very well with picking up different types of answers. Okay, And then we move on to question number 11. Consider the plate boundaries in both California and Washington. Okay, why do you think the depths in Washington are different than California? Okay, so think about their plate boundary and what would drive them to have either deeper or shallower earthquakes. Okay, now we're going to unclick Display Earthquakes. And then we're also going to display volcanic centers and then draw the map. Volcanic centers, draw the map. Okay, so now we can see all the volcanoes on the Pacific Northwest. So these that are in kind of a line here are known as the Cascadian volcanoes that extend from Northern California all the way through Oregon, Washington, and up into Canada. Okay, so we're going to look at the Cascade volcanoes from Northern California to Vancouver. Is there any correlation between plate boundaries and the volcanoes? If so, which boundary? Okay, so which boundaries do you see where you have most of these volcanoes? So remember, you can look at the plate boundaries here, and you can come down here and decide what type of plate boundary you're seeing. Okay, so you're going to write or click on whichever one you think it is. Okay, and then we're going to zoom out of the Pacific coast. Other than Cascades, do you notice any other plate boundary volcano correlations? Okay, so if we go up here and we zoom out, this is similar to a question you had on one of those other websites. Do you see a correlation between where most of the volcanoes are and the plate boundaries? Remember, this is the ring of fire, the ring around the Pacific plate of where all the volcanoes lie. Okay, so think about that, and you'll give a description in this text box. Okay, so based on what you've observed so far, what plate boundaries are associated with volcanoes? So make sure you're clicking on all that apply. Okay. Next question here, we're going to display vectors again. We're going to show 1 and 20, and we're going to unclick or unselect display volcanic centers. So we're going to undo those, display the vectors, and we're going to show 1 and 20. Draw the map. And here we're going to get a lot of them, but we're going to zoom right back into California because that's what we're going to work with now. Okay. So here we are in California. Hopefully it'll load in a second. A little slow. Okay, so this is going to be asking us to look at the area between Bakersfield and Redding, which is most of the Central Valley. Okay. So remember, the length of the arrow represents the velocity. So the longer the arrow, the faster the rocks are moving there. Okay. So what do you notice is the difference between coastal California and the Central Valley? Is there any correlation there? So you notice that these guys, it'll load, most of these guys are longer than the ones here in the valley. Okay. So you want to give some sort of description as to which ones are longer and why they might be longer. Okay, just give a comparison. All right, in general, which direction is California moving? You should be able to figure that out. Remember, north on this is towards the top of the page. This one doesn't actually have north arrow on, does it? But for the most part, whenever you're working with an online map, a lot of the times they are pointed north, so the top is always north. So remember, north is this way, east is this direction, west is this direction, and south is this direction. Okay. Now you're going to display vertical rates and click Draw Map. So we're going to go over here and we're going to do Display Vertical Rates, and we're going to draw the map. Okay, so now we have the vertical rates on our map, and we're going to answer the corresponding questions. So we're looking at the vertical rates along the San Andreas Fault. Remember, that runs through coastal California. What is the approximate range of vertical speed along the San Andreas? So we come over here. This red line is the San Andreas Fault. Let's zoom out just a little bit. So we basically have gray, yellows, a little bit of orange, and some blues. So if we look down here, we are looking at a range of maybe up to 3 and as low as -3 millimeters per year. So then you would find that on your answers, and that would be it. Okay, then you're looking at what is the vertical speed of Fresno. So come over here, we'll look at Fresno. Fresno is a blue, so I would say right around in this range. Okay, so then you would click your answer. Is Fresno moving up, rising, or down, falling? Note that the negative numbers indicate falling and positive numbers indicate rising. So what did you get for Fresno? And then write whether it's rising or falling. Okay, then you're going to look at the Sierra Nevada. Is it rising or falling? Okay, so we'll go over here. So the Sierra Nevada has some yellow, some orange, a little darker orange, a gray. So we're in kind of this range. So would you consider that rising or falling? Okay. And then this last question here is getting you to better understand plate motion. So the Pacific plate, in general, we say is moving northwest in relation to the North American plate, and we say that the North American plate is moving southeast. But if you look at these velocity vectors, it shows that they're both moving in the same direction. So if you look at, let's get rid of the rates, and we just look at the velocity vectors. You see that the coastal California has these longer vectors, which means it's moving quicker than the North American plate where we have Fresno, the Sierra Nevada. As you move inward, you see that those arrows get much smaller. Okay, so think about why that would be and how that would look. If you need extra help on that question, this is a really good video to watch to kind of help you understand a little better. And so in 25 to 50 words, you'll just describe that here, and then you'll submit quiz when you're done. I hope this helped you guys a lot better understand what is expected of you and what you need to be learning. All right, see you guys later. Bye.